So welcome to 1.4. So one of the good news things you should learn in Algebra 1 is that if you have a fractions in problems, you can get rid of them every time. Fractions can always be gotten rid of in an equation, and we're going to learn that today. So let's solve these problems. So there's a one-step equation. We're subtracting 21 from both sides, and x equals 15. So that's a one-step equation. So that's easy. Why is Mr. Ben put that there? That means he must be trying to teach us something. Let's see. So let's do number 2. We subtract 7 from both sides. We get 1/3 x equals 5. We multiply both sides by the reciprocal of the coefficient. Interesting, we get the same answer, 15, as the last one. Wonder why that is. Let's try another one. Here, a two-step equation, nice easy one. 2x equals 12, divide both sides by 2, x equals 6. Ooh, there's decimals. All right, so we subtract 0.6 or 6/10 from both sides. We get 0.2x, and then we subtract here, we get we're subtracting there, 0.2, and we get 1.2. We have to divide both sides by 2/10 or 0.2. Now we have 1.2 divided by 0.2, or 1 2/10 divided by 2/10. Now you're not allowed to have that out there. Who knows what to do, right? You have to move this decimal point over there and make that a 2. But if you do that, you have to move this decimal point over there and make that a 12. And so the problem that has the same answer as that is 12 divided by 2. And the answer here is still 6, like the last one. So what's going on here? Well, what I did to equation 2 is you can always get rid of this fraction here. You can get rid of all the fractions in an equation. And how you do that is multiply both sides by the same amount. Remember, I told you, we're going to be doing everything to both sides, not just to find answers this year. So what I did was I took this equation and I multiplied this entire side by 3. And notice what you get. 3 times 1/3, those cancel, and you get x. 3 times 7, 21. 3 times 12, 36. By multiplying that whole equation, both sides by 3, I made this much easier equation. And you can always do that. Same thing here. I took that equation with all those decimals in it, and I multiplied it by 10 on both sides. All right, now we'll show you this in a second, but I multiplied both sides by 10. If you multiply 0.2 times 10, the decimal moves over and becomes a 2. Multiply 0.6 times 10, the decimal moves over and becomes a 6. You multiply 1.8 times 10, the decimal moves over and you become 18. These two equations are equivalent, it's called. But one has no decimals in it whatsoever and is really easy, and the other one is slightly harder. And you can always get rid of fractions and decimals from your equations. So here's an equation with lots of fractions. We wouldn't get rid of the fractions you saw in that warm-up example. We did those yesterday or in the last lesson. But when you have lots of fractions, right, you could sit there and absolutely you could add 3/5 to both sides and do that. But it turns out it's usually easier just to multiply both entire sides by 5. And if you multiply both entire sides by 5, you get to cancel all those 5's in the denominator, and you get that nice easy equation to solve and get x equals 8. So let's see that today. So you're going to multiply both sides to cancel the denominators. So we're going to multiply both entire sides of the equation by 4, right, to get rid of that 4 down there. So we're going to multiply, let's use a different color. So this entire side, so that has to get multiplied by 4, that has to multiply by 4. Now the key, you also have to multiply the other side by 4. Right? Properties of equality say that you must do everything to both entire sides. We are always doing that. So 4 times 1/4, right? If you had to do 4 times 1/4, those cancel and become 1, or 1x. 4 times 3/4, those cancel, and that becomes 3. 6 times 4 is 24. So now we've made that equation into x plus 3 equals 24. We subtract 3 from both sides, and x equals 21. Right? Imagine if you didn't have this trick. What would you have to do? You'd have to subtract 3/4 from both sides. Right? And you get 6 minus 3/4 is 5 1/4. And you could do all of that. But it's way more work. So no one does. We clear our fractions, it's called. So let's try this one. What would you multiply both sides by? So you'd multiply this entire side by 7 and that entire side by 7. The 7's there cancel out and you get x. We have a minus sign. 7 times 3 is 21. These 7's cancel out and you get 5. We've turned a tough two-step equation into an easy one-step where we just add 21 to both sides and get x equals 26. Yeah, if you go back and put 26 over in there, 26/7 minus 3, all right, minus 3 equals 5/7. Yeah, and that would be clearer if I wrote 26/7, right? 7 goes into 26 3 whole times. That's actually 3 5/7. So what the original equation was 3 5/7 minus 3 equals 5/7. Yeah, it checks. So let's practice that. Now, we're going to do a little harder ones, right? Those were nice and easy. So now we need a number that's going to cancel both the 6 and 3. And the number you need is the good old least common multiple. So, least common multiple. Remember, when you had, say, 1/3 plus 5/6, what would be the denominator you would use to add those two together? The denominator you would use is 6. That's the least common denominator. It's the least common multiple. Same thing here. The least common multiple of 3 and 6 is 6. So we're going to multiply both entire sides by 6. You're not going to multiply by 3 because 3 won't cancel everything out, as you'll see. So let's see that. This 3 cancels with this 6. Now 3 goes into 3 once, 3 goes into 6 twice. So this doesn't become x, it becomes 2x. All right. These 6's cancel out and that becomes 5. This 3 and this 6 cancel, but 3 divided by 3 is 1, 6 divided by 3 is 2, but we have 2 times 2 is 4. Now notice I didn't say solve. So we're just going to practice clearing the fractions, right? We all could solve that very easy equation. So let's try again with another one. All right, so what number would clear both 2 and 7? It's the least common multiple of 2 and 7. Well, it's 14. Right? You multiply both entire sides by 14. 2 goes into 14 7 times. This becomes 7x. 7 goes into 14 2 times. So we have this minus sign, and we have 2 times 5. I really should be writing a multiplication dot everywhere here. And so 2 times 5 is 10. This 7 cancels with this 14, becomes 2. 2 times 2 is 4. And that's the two-step equation we could solve. Try that one. And now you're going to solve it, it says. So what would clear both the 5 and the 2? It's 10. 5 times 2. So this 5 becomes a 1, and that 5 becomes a 2, and we get 2x. This 2 cancels with this 10, becomes a 5, so we have plus 5 times 1, 5. This 2 becomes a 1, and this becomes a 5, and we have 5 times 7 here is 35. And so this is the equation we'll solve instead of the other one. And we get x equals 15. Now, if you wanted to subtract 1/2 from both sides, yeah, you could. You'd get 1/5 x. 7/2 minus 1/2 is 3/2 is 3. This one in particular isn't that hard, right? You'd multiply both sides by the reciprocal, and you get the same answer, 15. But generally, clearing your fractions is the easier way to go, and it's actually required in tonight's homework. All right, so which equation of these is equivalent, right? They have the fractions cleared, so you have to pick one. So we'll multiply everything by 10. The 5 cancels with the 10 becomes a 2. So we get 2 times 2 is 4. All right, so it looks like we're going to start with 4x. It's not b. Then we have minus. This 10 cancels with this 10, and we get minus 3. So it's looking like it's going to be a, but let's double check. This 10 cancels with that 10, and we get 7. Yeah, these two have the same solution. That's called being equivalent. All right, so we're going to combine this with yesterday. Now, mixed numbers cannot go into equations. We never write 1 1/4 x. Your choices are 5/4 x, the improper fraction, right? You multiply 1 times 4, add it to 1. Or you could make it 1.25x if you wanted to deal with decimals. I would like you to do this with fractions, but decimals would work. So let's see that. So 1 1/4 feet per week, that's our rate, right? Our rate goes first, and then at whatever the variable is. So we're going to use, so it says make the mixed numbers into improper fractions. So we have 5/4, and we're going to use W for weeks. We're finding out how many weeks we have here. And when we started, we were at 6 1/4, right? So 6 1/4, right? Multiply 6 times 4, 24 plus 1. That's the improper fraction, 25/4. And we're currently at 12.5. Our total height here is 12.5, right? 12.5. 2 times 12 is 24 plus 1 is 20. Whoops. 25 halves. I almost thought it was 25/4. So that's 25 halves. All right, so now we have a bunch of fractions. What do we multiply by to clear them? Well, we have 4 and 2, so we multiply by 4. These 4's cancel, we get 5w. These 4's cancels, we get 25. This 2 divided by 2 is 1, 4 divided by 2 is 2. We have 2 times 25 is 50. That's the two-step we're going to solve. 5w equals 25, divide by 5, and we got 5 weeks for the age of this sunflower. Mixed numbers are always made into improper fractions in equations. And this is why. When you have 1 1/4 weeks plus 6 1/4 equals 12.5, right? That starts to look like 6 times 1/4. That starts to look like 1 times 1 1/4. We never do that, okay? It's improper fractions or decimals. Okay, so now I want you to remove x from those denominators. What would you do? So we're going to multiply everything by x to get rid of x. That cancels out, and that's 5. X times 4 is 4x. Those x's cancel out. You get 12. 5 plus 4x equals 12. Subtract 5 from both sides. 4x equals 7. Divide both sides by 4. The missing number, that denominator, is 7/4. Now, right, there's really no other good way you could figure out that that denominator was in fact a fraction. And yes, can you have fractions in a fractions? Yes, they're called complex fractions. You can have 5 over 7/4 and so on. All right, so what would you do to both sides here? You'd multiply by x. So you have 2 equals 8x. All right, divide both sides by 8. X is being multiplied by 8. So x equals 2/8, but you would never leave it that way. You would simplify. And so x must be 1/4. Right? 2 divided by 1/4 equals 8. Yeah, it does. Try this one. All right, now this is, right, when you were in 6th grade, maybe your teacher had you do, oh my God, cross multiplication there. And you could do this way. But let's see what happens if I multiply. Now let's see if you do cross multiplication, right? You get 3 times x equals 2 times 5, which is 10. You get that. Divide both sides by 3, and the answer is 10/3. Right? Well, what are you doing there? Well, you're clearing these, you're multiplying both sides by 5 times x. That's what you're doing, all right? Because the least common multiple of 5 and x is 5x. So these x's cancel out, and you get 2 times 5. There's your 10. On this x, these 5's cancel out, and you get 3 times x, or 3x. Cross multiplication is a trick, but it isn't a rule. The rule is you have to multiply both sides by the same amount. And in this case, that same amount would be 5 times x. All right, so we did it with fractions. Now we're going to do it with decimals. Now, to clear the fraction, we're going to move the decimal point the same amount in each location. So, right, it's obvious to move it in these two where you see the decimal point, but you have to move it in 3 because you have to do everything to both sides. So all we're going to do is clear the decimals. So 0.2x becomes 2x. 0.6x becomes 6. 3 now becomes what? It becomes 30. That's the equation that has the same answer as the one we started with. Let's practice another one. All right, so you have to move it the exact same amount every time. So how many times are we going to move the decimal point here? Well, we're going to move it twice here, so that to make that 3x. Otherwise, it only becomes 0.3x. The decimal's not gone. It's not cleared. But once you do that, you got to do it here twice. So that becomes 20, right? Empty spaces always filled with zeros. And you got to do it here twice. You got 11. So what's going on there? I said the rule was you have to do something, multiply, add, subtract, divide to both sides. Well, what moves the decimal one time? Well, what you're actually doing there is you're multiplying both entire sides by 10. Multiply both entire sides, the decimal will move over once. So what did we do here where we moved it twice? We multiplied both entire sides by 100. All right, you don't have to write that out. You just have to know that you're moving it the same amount in every single term. All right, so how many times would we move the decimal point? And now you're going to solve it. So we're going to move it twice there and make that 9x, right? Because there's no such thing as 9x. We're going to move it twice there. That becomes 10. Move it twice there, all right? And this is usually where the mistake is if there's a mistake. That has to become 370, right? You don't just move it to the, some students just want to move it to the end. No, it's the same amount of moves in every location. So decimals are gone all over the place. So then we're subtracting 10 from both sides. That's subtracting 10, not adding. And 9x equals 360. Divide both sides by 9. I'm running out of room. And x equaled 40. Yeah. Now, again, well, just like with the fractions, could you sit there and subtract 0.1 from both sides? Yes, you could. And you would get 0.09x equals 3.6. Then what would you have to do? You'd have to do 0.09, divide by 0.09 on both sides. So then you'd have to do 3.6 divided by 0.09. And what would you have to do? What do you have to do right here? The exact same thing we did here. So you have to do the exact same thing, move the decimal twice, but you had to do extra work to get there. Better to do it at the beginning, right? You'd move this twice and make that 9, move this twice, make it 360. Yeah, and the same answer, 40, all right? But we want to clear the decimals right off at the beginning. That way we don't have to do all this at the end. Makes our life easier. And you can do this in any equation with fractions and decimals. If there's one simple little fraction or one little decimal, you don't have to do this, right? You want to do it when there's lots of them to make your life easier. Okay, so we're going to combine this with word problems. So we have the rate is 50 cents per ride, R for rides. It was $10.25 to get in. And we have a total of $31.75. Now we could do that all with the decimals, or we can move it twice everywhere. And we get 50R plus 1,025 equals 3,175. Subtract 1,025. Divide both sides by 50. Take advantage of the fact that you can cross out those zeros at the end. And we're still going to have to do 215 divided by 5. 5 goes into 21 4 times. 5 goes into 15 3. And remember I told you these rides are ridiculously cheap in this problem. And so you get 43 rides because they're 50 cents per ride. All right, so do these two practice and then check your work. So we have 7, 14, and 2. What is going to clear those all? Now think about if you had to add 1/7 plus 3/14 plus 1/2. What denominator would you use? Hopefully you're saying 14, right? That's what you have to multiply all three terms by. And all the denominator, right? You'll know if you pick the wrong number. You'll usually pick something too small if you do. And the fractions won't go away because you pick something too small. 7 goes into 14 twice. These 14s cancel. 2 goes into 14 7 times. 7 times 1 is 7. So we're going to solve that problem. Add 5 to both sides. 2x equals 12. Divide by 2 both sides, and x equals 6. Oh, I didn't say solve it. No, I did extra work. Write an equivalent equation with whole numbers. That's all you had to do. All you had to do was 2x minus 5 equals 7. All right, we have an x and a 3. To get rid of that, multiply both sides by 3x. These x's cancel. You get 8 times 8 is 24. These 3 cancels. You get 2 times x. Divide both sides by 2. X equals 12. Is that the same thing as your cross-canceling from 6th grade? Yeah, it is, right? You get the exact same equation. But now you actually know the real rule behind that. All right, so all it says is write an equivalent equation. So how many times you're going to move the decimal point? Right, 1, 2, 3 to make that 9x. But once you do that, 1, 2, 3, that must be 800. 1, 2, 3, that must be 8,200. That's the equation with the same answer as the one we started. So now you're solving. So we're going to move it twice for 0.54 and make that 54. Move that twice and make that 4x. And move that twice and make that 30. Add 30 to both sides. 84 equals 4x. Divide both sides by 4, and I think 21 is what equals x. All right, final question. Apples cost $1.50 per pound, and we're doing p for pounds. The membership fee was $50.75, and we have a total of $54.50. It doesn't say solve it, all right? So you could leave it that way, but if you had to solve that, you could change this to 150p plus 5,075, right, equals 5,450. You move the decimal twice in all three locations.